Okay, guys, this is going to be the set of notes for Titan Learning Day 35 and 36, the double angle and half angle identities. Again, don't worry about memorizing these. You're going to have the papers. I just want you to know how to use them. So double angle identities, you've got 3 for cosine 2 theta. So for cosine 2 theta, you can use cosine squared theta minus sine squared theta. You can substitute 2 cosine squared theta minus 1, or you could say 1 minus 2 sine squared theta. For sine 2 theta, you can use 2 sine theta cosine theta. And for tangent 2 theta, you can use 2 tangent theta over 1 minus tangent squared theta. So double angles mean they're just doubled, 2 theta. That's what it is. Okay, how do you derive a double angle identity? So you can derive the identity of cosine 2 theta equals 1 minus 2 sine squared theta, this one. First, you're going to use the Pythagorean identity, which is sine squared theta plus cosine squared theta equals 1. And you're going to rearrange that and get cosine squared theta equals 1 minus sine squared theta. So now you can say cosine squared theta equals, in place of the 1, I'm going to write, wait a minute, now I'm lost. I'm sorry. Cosine 2 theta equals cosine squared theta minus sine squared theta. In place of the cosine squared theta, we're going to put 1 minus sine squared theta, and we're going to leave this here. Then we're going to have 1 minus sine squared theta minus sine squared theta. We're going to combine those and get 2 sine squared theta. So that's how we would derive that from our initial statement. Now, using a double angle identity, it says, what is the exact value of the cosine of 120 degrees? Use a double angle identity. So what we're going to do is we're going to say, what times 2 is 120 degrees? So that's going to be 2 times 60. So now we're going to use what we know from here, and we're going to say cosine squared 60 minus sine squared 60. And we're going to figure out, okay, the cosine of 60 is 1/2. The sine of 60 is square root of 3 over 2. We're going to square both of those, and we're going to simplify and end up with an answer of negative 1/2. All right, rewatch the video slower, go through the steps. If you don't understand something that I've done, let me know and I'll re-explain it, or send me a question about it. If we need to meet live, we can do that too. All right, let's say we're going to verify an identity. We're going to verify the identity cosine squared theta equals 1 minus tangent squared theta over 1 plus tangent squared theta. So I rewrote it. And I said, okay, if I use our Pythagorean identity, I can change 1 plus tangent squared theta to secant squared theta. So now I'm going to split this up and say 1 over secant squared theta minus tangent squared theta over secant squared theta. And I just wrote it as 2 fractions. Then secant squared theta is 1 over cosine squared theta. So I've got 1 over cosine squared theta, which just will end up giving me cosine squared theta. On this side, I'm going to write sine squared theta over cosine squared theta, and I'm going to convert secant squared theta into 1 over cosine squared theta. So I've taken all my pieces and I've expressed everything in terms of sine and cosine. Then on this side, I would have sine squared theta over cosine squared theta divided by 1 over cosine squared theta, which will actually be this times the reciprocal, which is cosine over 1. So the cosines would cancel, and I'm just going to end up with cosine squared theta minus sine squared theta. And that is going to simply be cosine 2 theta from our cosine double angle identities. All right, let's look at half angle identities. Half angle identities are going to be the sign of, we're splitting angle A in half, and it's going to be plus or minus the square root of 1 minus cosine A over 2. Splitting angle A in half, plus or minus 1 plus cosine A over 2. Splitting A in half, plus or minus 1 minus cosine A over 1 plus cosine A. Okay, now you're going to have to choose whether you're going to use the positive square root or the negative square root, depending on the quadrant in which your angle lies. All right, so let's look at a couple of examples and that's going to make more sense. So let's use our half angle identities. And the first example is what is the exact value of each expression? Use the half angle identities. And I'm going to try and find the sine of 15 degrees. So I've got to rewrite it as a half angle identity. So sine of 15 degrees would be 30 divided by 2. And now I'm just going to follow the rules. That's going to be the square root of 1 minus cosine 30 over 2. I know that the sine of 15, my original, lies in the quadrant that's going to give me the positive square root. So I'm going to have a positive square root when I solve this. I'm going to figure out what the cosine of 30 is. It's going to be the negative, well, actually I'm subtracting it. It's going to be the square root of 3 over 2. So under the big square root, I've got 1 minus square root of 3 over 2 all over 2. And now I'm going to say, okay, I can multiply everything on the top by 2 to get rid of my fraction. So that's going to become 2 minus the square root of 3 all over 4. I can actually take the square root of 4. So the bottom loses the square root and becomes 2. And the top remains 2 minus the square root of 3, and I'm taking the square root of all that. Okay, let's look at cosine of 150 degrees. That would be 300 degrees divided by 2. And I'm going to use a negative square root since the cosine of 150 would be negative. Okay, now let's look at what we substitute. We are going to substitute 1 plus cosine of 300 all over 2, and I'm using the negative. That's going to become 1 plus 1/2 over 2. When I simplify that, that's going to become the negative still on the outside, the square root of 3 over 4. I can take the square root of 4, which is 2, and the top is going to be negative square root of 3. Okay, go through it again, see if you have any questions, and then you can ask me those questions on my mind. Okay, one more example. We're going to use a half angle identity. And I'm given that the sine of theta is equal to negative 24 over 25. And this is going to be, theta is lying between 180 and 270 degrees. So which quadrant is that going to be? Yes, quadrant number 3. I want to know what is the sine of theta over 2. So first I'm going to start with the Pythagorean identity, which is cosine squared theta plus sine squared theta equals 1. Now, can I substitute in for sine squared theta? Yep, I can. So cosine squared theta plus sine squared theta, which is going to be negative 24 over 25 squared, equals 1. So then the cosine squared theta equals 49 over 25 squared, and cosine of theta will be the negative 7 over 25. And I'm going to choose the negative because theta is in the third quadrant. Okay, now that's not what we're looking for. We're actually looking for the sine of theta over 2, but we had to locate that in order to figure out how to do the next part. So if we were starting with theta between 180 and 270, theta over 2 would have to divide both of these in half and would have to lie between 90 and 135. So that's going to put it in quadrant 2, okay? And we know that it's going to be positive in quadrant 2 for theta over 2. So now I'm going to say the sine of theta over 2 equals plus or minus 1 minus cosine theta over 2. We're going to choose the positive. So 1 minus, from up here, what is cosine? That's the reason we had to find it. Negative 7 over 25 over 2. So that's going to be 1 plus 7 over 25. Okay, all over 2. We get common denominators and solve the fraction. And in the final answer, we're going to get 4/5. If you get hung up on the fractional part, let me know, and we can work it all the steps out. I think you guys should be pretty good at that by now. But if anybody has any problems, let me know, and I'll work it out and send it to you on Remind. If we need to go through these on Hangouts so everybody can understand all the steps, that's fine with me. Just let me know. But these are the notes for those 2 Titan Learning Days, and let me know if you need any help.